Okay, thank you. Thank you. So let me start saying this. While we as a company, we cover a variety of open source databases, PostgreSQL included, I'm not really their big Postgres experts, right? A lot of my technical career, before I kind of switched to the dark side and became CEO, was with MySQL. So that is where my background comes with. And this is why we are talking about the MySQL distributed architecture here, right? So what we'll do is cover some basics, review the history of the approaches to the distributing MySQL data, look at the current state of technology, again, about the MySQL landscape, and what future is likely to bring us. So I have about 30 minutes, which I just said I am having less time, so I will have to move very quickly in this topic. So I'll have to gloss over some details, right? And so that may not always come from the fact that I'm just a clueless CEO, but it's sometimes maybe just due to the time pressures. So what do we call the distributed, right? For my sake, we just call distributed deployments of MySQL. We actually have a data distributed in more than a single MySQL instance within a single environment, right? Just for simplicity. One thing I want to start with is to say, if you look at the MySQL and frankly any other modern database, what the hardware we are getting those days is very powerful, right? And really, if you take a single MySQL instance, you can often get a lot from this instance, right? So in this case, we see MySQL handling more than 1 million queries a second on a single node. Actually, if you really use a very simple queries, right, on very powerful box, you can push it to 2 million and beyond, right, on the single node. Now, in reality, you can think about those hundreds of thousands of queries a second, right, for a number of applications, and tens of thousands of updates a second, and so on and so forth, right? So what that means is MySQL can handle some pretty reasonable applications from the single instance, right? Of course, you're not going to be able to run, Facebook on the single MySQL node, or even something smaller like Twitter. Also probably would require more than one MySQL instance. But if you look at a lot of small and medium-sized applications, in the enterprise and wherever, their single application, right, or some simple high availability practices may be quite good enough for you, right? Now, why I point this out? Because as I see a number of people, especially in the MySQL space, move to those kind of distributed systems, then they really have to, complexity increases a lot. Again, especially in the MySQL space. For example, you set things up like you have a master and slave, and guess what? Now you have to deal with a case when MySQL slave is not completely up to date. Right? Or if you have a data which is spread out on a different nodes, you have to think, oh, how many nodes my queries are going to touch, because in many cases that can be driving query latency, right? And so on and so forth, right? There also can be a lot more, complicated failure modes which happen in distributed system, right? If you look at all those kind of things which can go with network partitioning, right, and various asymmetrical failures. Oh my gosh, it's so much more complicated compared if you have a single database which can be up or down, and that's pretty much all you have to think about as application behavior. Now, with all of that, why do we go distributed, right? Why large-scale applications are distributed large is, I think there's pretty much three big reasons, right? High availability, you can do it with one node. Scalability, again, you can scale beyond certain thing within one node. And also their data distribution, right? What I mean by that is, for example, for legal reasons, if you're running a large-scale system, you may not be allowed to keep one data in one instance, right? Or even in one country, you have to may have to do that, right? One thing I think what is very important when you speak about the data distribution is how you really set up your data propagation, right? Because of the realities of a speed of light, which wasn't solved by even by, the modern cloud providers, which offer us all kind of magic, right? They still have to live within the constraints of physics, with the speed of light being a very important one for them, right? And so that means is when it comes to the globally distributed systems, you have to typically deal with either replication happens synchronously, which is slow, or when replication is asynchronous, right? When you deal with delayed propagation, right? Data log can occur, right? Or your application sort of isolation mode, right, becomes different. When we speak about scalability, I think it's important to understand what scalability you are really after. And depending on your application, you may need to scale one or all of those dimensions, right? Scaling reads, scaling writes, and scaling to be able to deal with a data size, right? So for example, if you look at the MySQL, we very often use MySQL slaves, right, replication, for scaling still. And it's very good if you need to scale your reads, but that's kind of quite helpless, right, if a scaling writes or scaling the data size you're after. And already I mentioned the data distribution, right, which can be important either for some legal and compliance reasons, right, or for user latency reasons, right? You may want to bring your data closer to users. So let's now look at the MySQL distributed architectures, and especially in the early days. Now, it's all started with a classical MySQL replication, which was very good in scaling reads, but not so much scaling writes. And in the early years, people have been obsessed with MySQL replication, right? I remember we had people using like multiple layers of MySQL replication. I remember some folks would have up to 150 replicas of the same data set, right? That's probably sounds crazy those days, right? I mean, and I don't know, like Harrison, you worked with me in MySQL support at the time, so you may remember even high numbers, right? So many copies of data. How does that classical MySQL replication works? Well, pretty simple, right? We have master, which writes binary log, which eventually make it away to relay logs on the slave, which applies them. With that architecture, we could use a lot of different topologies, right? Or at least we can use them now. Now we can have a multi-source replication. We can have a multiple master, so kind of consolidating the replication to a single slave. We can have multi-tiered replication. You can even have the ring replication, which is very much known as a MySQL replication food gun. Because if you use ring replication with MySQL, you are almost guaranteed to have problems sooner or later. Now, the thing I like about, or illustration about the problems with MySQL replication, I like comes from Brad Fitzpatrick, right? And I took some pictures from his presentation back from 2004, right? So it's 15 years ago, right? Which says, hey, you know what? If you have a slave and they have one server, right? They have so many reads and so many writes. I move two servers, it's kind of scales well. But now if I want to scale, right? More and more writes are being handled. Sooner or later you have your replicas just all they're doing is handling writes. There is no space left for handling reads, right? So it's kind of sucks, right? Now, back in the 2004, MySQL replication already used their MySQL sharding approach, which kind of slightly evolved, right? We're having new techniques developed, right? In sort of how to select the shard keys and so on and so forth, right? But in the end, it's very much similar to what is being used even at this day, right? We can have some what is called global cluster. That's where the metadata about the shard location is stored, right? And then there is bunch of shards, right, which store, right. Interesting error, we can see at that time, we still treated our servers as pets. We give them names, right? No more than, just, some automatically generated server numbers, right? What are other problems operating at scale? We have asynchronous replication, right? That means the data may be stale, depending on how lucky you are. It can be very stale, right? We have seen some customers which would neglect or not plan capacity for replication probably, and would have the slave delayed by a week, right? Replication, which is also not quite crash safe on slave and on master. That means if crash happens, you may have a hard time fixing it, or may lose some data. Non-atomic DDLs in MySQL contributed to that as well. Single-threaded replication, that obviously became increasingly more bottleneck as our servers became a lot wider, but not significantly faster when it comes to the CPU cores. Statement-based replication in MySQL also has been a problem as, it was discovered for discovered, but not all SQL statements are really deterministic, right? And that means statement replication alone is kind of problematic. And also the automatic failover, right? If you look at simplistic MySQL master-slave replication, if your master fails, slave will just sit out there and say, well, you know what, my master fails. I don't know what to do, right? So that is not enough for your really high ability experience. Now, if you look about the sharding, most people think about the sharding, the problem as, well, how do I route my queries? And there have been a lot of frameworks designed with that little purpose in mind. But if you really look at at sharding at scale, that is not the really most complicated problem, right, which you will have to be dealing with scale. One is that you will likely have as queries, right, or at least application data access need to span through more than one shard, right? You have to deal with that some way, which is much more complicated problems. And also shard rebalancing online, right? Even if people who did a lot of very smart things and saying, hey, we are very careful, all our shards should be balanced, we'll find sooner or later what their shards are not balanced because life is tough, right? And we'll have to deal with that in some way. So that is another kind of complexity of good replication solution. Now, MySQL is good for many things, but it's not good for everything. And I think that was very valuable. What was discovered by MySQL community. And MySQL community was always very open, supplementing MySQL with various technologies, right? Being that full text search, caching, doing various non-relational data stores, which MySQL may not be great at, or various technologies which you can use for data analytics, which MySQL is horrendous, considering it still doesn't have a very advanced optimizer, and it's also uses single-thread query execution model, right? So you cannot parallelize the queries. Now, one thing I also should mention, if you talk about the sharding, is MySQL NDB cluster solution, which is kind of really is a very sad story, right? Because that was the very advanced NoSQL before that term was invented, right? And it gives all that kind of transparent sharding for you, right? Because before new SQL was popular, but it really never took off in the end, right? It's still used for some very important workloads in the niche applications, right? In this case, but I think the story there, what NDB cluster kind of came to the market with a lot of promise. A lot of people tried that and say, oh my gosh, that is so complicated. Performance was so tough, right? And I didn't want to try it again. And even if now MySQL cluster has did a lot of strides, right, in the last decade, we still don't see that really hitting the mainstream anywhere nearly as MySQL. Okay, let's look at MySQL, distributed MySQL now, right? What has been happening. So if you look at the Sharding, Sharding is a king, right? Again, if you look at the building large-scale solutions with MySQL, like there is no way around that. Again, we can do much larger databases with MySQL right now on the single instance, right? I have seen people, running maybe 50 terabyte database on a single node and quite happy about that, right? We probably wouldn't see that a decade ago, but there are still the limits. How is that sharding implemented? Now, I think what is very interesting in MySQL is because of its originally not having any sharding built in, many organizations invested in their own sharding implementation in some solutions, right? If you look at a lot of the Silicon Valley large-scale companies using MySQL, many of them has some of their own sharding frameworks. And I think that is very interesting if you compare MySQL to, let's say, MongoDB, which in the very early days provided sort of a standard sharding framework. And while early MongoDB sharding framework implementations had a lot of limitations, right? Because that kind of became the standard, right? They gradually improved that while keeping users on that, right? That just didn't happen in MySQL because of it. So if you look at the sharding, what technologies appear right now, right? I would say Vitess is probably the leader in this space. That is technology which was used by YouTube for many years, right, until the founders left and now started their own company called PlanetScale, but they still chose to keep Vitess available as an open source. Now, if you're just looking for some simple sharding, like routing the queries, you can do that with tools like ProxySQL. Of course, that doesn't solve really complicated problems like library sharding or handling complex multi-cloud queries. But for some workloads, right, for some simple cases, we have done it, and that worked pretty well. And also, you can find many unknown quality projects, abundant on GitHub when it comes to MySQL sharding, right? Because a lot of people started that, and this kind of problem looks so attractive and so trivial if you just look at the surface, right, and not really understand all the complexity. So MySQL replication. MySQL replication has been also significantly improved, right, over the years. Now it can be configured so it's actually crash safe on the master and the slave, right? So if you lose your power on a master or lose the power on a slave, it's can restart the replication. The semi-synchronous option was done to avoid the data loss, right? Which I know, again, a lot of large-scale companies are using that. Now we have parallel replication. That means replication throughput is not limited by how much single thread can execute. We have multi-source replication, which allows us to build even kind of more complicated topologies than ever before. With MySQL 8, there also came atomic and a crash-safe DDLs, right? So that also helps to have a replication even more secure, right, at scale. Row-based replication, that has been in MySQL for a while right now, and that really, in its form, like as a row-based replication or mixed-mode replication, can really give you a very robust replication which can handle, any kind of workload. And another piece of innovation which is important is called the orchestrator. That is the tool which allows you to manage failover, right, in MySQL master slave in an automatic way. That has been popularized right now by GitHub, which run a lot of workloads on application. It's also used by many others, right? If you're using classical MySQL replication, right, and you don't want, you don't have your own secret solution, right, which is not open, the orchestrator is a leading choice. If you look at the MySQL cluster, and when you want to have a sort of batteries built in, right, instead of some external tool managing that, there are two approaches, right? One is Galera, right, which we also provide from Percona under product name as Percona XRB cluster, and there is also MySQL group replication, which is also often called MySQL InnoDB cluster. In both cases, it gives you much more, I would say, modern idea than nodes know they're part of a cluster. If one of them fails, cloud does election, and somebody else cluster does election, and somebody else becomes a primary, right? Okay, now let me end this by talking about the future. But before that, I want to just make a little bit of a statement, right? It's hard to make predictions. By the way, this is attributed to Yogi Berra, but I think what Niels Bohr was actually early author of this quote. Anyway, so desire for scale is remaining, but I think what is interesting, what I find, is the huge gap between the team which actually need that massive scale and the teams who want it. Because every kind of company say, hey, we want to become the next, Facebook, right, or some very popular online games. And if that happens, even if it's very unlikely to happen tomorrow, we don't want to be limited by our database, right? And because of that, we want to have a database which is web scale, right? That is one of those original, let's say, MongoDB selling point. Now, another things, I think what I also find is because of that, many people are looking at their scalability, which they may need in theory, right? Even if the system which we design may not be as efficient, right? Which otherwise. I mentioned the new technologies, right? I think Vitess has a fantastic future, right? I think Oracle recognizes what they need, sharding solution for MySQL, an official one. Especially right now, I think when PostgreSQL has Citus DB, right, solution. So that puts even more pressure on that. And I think the major cloud vendors, right? I mean, they understand that pretty well. They need solution for MySQL for sharding scaling MySQL, right? I mean, something like Aurora, as wonderful as it can be, right? It just pushes the scale a little bit, right? Even if you believe that benchmark numbers over 5 times faster, well, 5 times, is nothing, right, if you really want to go to a larger scale. We also have new scale technologies, right? If you look at the open source database space, I will mention Yugabyte, CockroachDB, right, which have a different approaches, but in a sense you have chosen to offer some MySQL compatibility, and the TiDB by PinCap, which offers MySQL compatibility, right? But in both cases, that is so completely new technology stack, right? It's not just, let's say, a proxy over MySQL. Another thing I think which is interesting, I see a lot of people are pushing for databases, is the separation of the storage as compute, right? Wouldn't it be wonderful if we can, store our database on something like S3, right? And then is spin up as many stateless processing node as possible. That exists in some form now for analytical workloads, but not so much for transactional databases. And we're also very excited in Kubernetes-based solutions like cloud native. I think a lot of people have been scared by early day Kubernetes, which is kind of, hey, you know what, stateless, right? But now Kubernetes is becoming better and better for stateful support, right? And I would expect we'll be able to run more databases, even kind of not designed specifically for Kubernetes on it, right? And get a lot of value, right, from that. And when it comes to database as a service, I think the big question for me, which I don't have a good answer for me, how things are going to be involved in this case, how many solutions which will be actually see as being the open source versus market share of those Cosmos DB, DynamoDB, Spanner, right, which kind of only proprietary. What I think is interesting in this case, and some of that stuff was developed in just last few weeks, right, we can see is what if there is a demand, the open source alternatives come. Right, so DynamoDB, which is like Amazon's obviously bread and butter, right now have got 2 implementation compatibility, right, for from data stacks of Cassandra and from SiloDB, right. Obviously, probably is not complete implementations, right, but it is great to see what open source community coming up with kind of disrupting the cloud in the same way you can see sometimes cloud disrupts open source, some open source companies. Yeah, and the last thing I want to say is if you folks are interested in open source databases, right, you may have some colleagues in Europe. We Percona run Percona Live in Europe. That's happening late September, early October, and we still have some tickets available. With that, thank you. I'm happy to take some questions while we switch, or I also will be available in the hallway for the rest of the day.